everybody, welcome back to MBE. Today I want to go over what goes into building a manifold with a valley tray, especially for something that doesn't have a provision for a valley tray. This is our Billet forward intake manifold. We also offer this in a cast version for some of the truck pullers, and we'll just go from there. So you can see this is completely machined. What's nice about this is it has all kinds of plenum volume. You know, this isn't too long here to fit in the rules, but it has plenum volume, short runners, and if you're concerned about weight, you won't have to be concerned with this because it's probably about 12 pounds. And then, so what we want to do is, so all of us here designed the manifold itself. So Bob and I had, at this time, Ian hadn't been here yet, but we had a lot of hours in designing the intake itself to make sure we had enough plenum volume, to make sure we had something that could be on 600 cubic inches or could be on a truck puller that was 500 cubic inches and that ran 9 to 10,000 RPM. So we designed all this with the short runners, short radiuses, small radiuses, and large plenum. But from here, then it gets difficult. And then we have to bring everybody else in the shop. So we got Ian's involved in it, Scott's involved in it, and Joey did a lot of the design and CAD work on this. So Joey, if you can talk about some of the things you did while I'm pulling off your plate that you designed.
Yes, so we had to make a spacer plate to cover up the back and the bottom, block all potential air. And on the spacer plate, we scalloped it out for weight. We also kept in mind of if you want to use water, so you can actually just drill right inside the scallop to access the water. The plate is O-ringed, which Matt will show you in just a second. And it's just, we removed every bit of weight we could to try to just make it as light but sturdy as possible. Used the biggest fasteners we could to help secure this plate into place.
Nice.
And developed the valley tray just the same way, just taking away as much material for weight as possible while leaving it nice and sturdy. Oops. So like here, you can see it's O-ringed around the intake ports and around potential water.
So that's the water, so that's all O-ring there.
Right.
Over on the intake port, so no silicone, nice and clean. And then the part Bob got involved in, well, we need to make this for so many different deck heights because you got 4 guys. This can go down to like a 9.6, and then you got 4 guys that are at 10.6, 10.7. And then what Bob suggested, and Bob can go from there with the plate.
So we designed the plate with that in mind so we can cover the cubic inch requirements and to allow engine builders for a short deck, high RPM application, or then also for these larger cubic inch. And on the intake manifold itself, we added provision for fuel injection or nitrous oxide. So what we've tried to do is we've tried to give ourselves the most options and keep our costs in check so it makes it more affordable for the racer, but so they get a highly designed, well-engineered package. And the spacers allow us to machine to different thicknesses, and they have the provisions for, like we talked about, the vacuum for the valley, and then also for the water provisions. And we can vary that thickness to adapt the manifold, which we don't have to redesign the manifold every time we change the application. And about the intake manifold, as Matt said, you know, the large plenum, short runner, but on a symmetrical head like a Ford, you can see how we did that. There was a lot of engineering went into that, where we have the straight runners. It's a straight shot on all 8 cylinders, and that's why the manifold's laid out the way it is. And it was a lot of work to get the spider, to get it to align with all the ports and the spacers. Joey did all the design so we don't have a big interrupted path to the air fuel into the combustion chamber.
And some of what's so challenging about this always is that, because the head comes scalloped where it needs to seal on the valley, so there's no way to seal it if you just put the manifold on there. So it looks easy because it came out so good, and when it looks easy, it typically is good, I would say, in any design with anything. But this is a lot of work and a lot of time to make sure that it works correctly. And so between Ian got involved in a bunch of this. He came up with the idea with just sliding this on there, and I thought that was wonderful. So that just simplified everything. And anytime we can simplify it, it's always going to be better. As humans, you know, our biggest issue is over-engineering everything. So if we can under-engineer it, then we usually come up with a better piece. But that is the MBE A-460 billet / cast manifold with the valley tray, with the plates that are O-ringed. And now a Ford guy has an intake manifold that'll make a lot of power instead of a design that's 20 or 30 years old. And that's certainly the issue with the Ford. The Ford doesn't get enough time spent on it. We actually spent some time on it. All right, I hope everybody enjoyed this, and have a great day. Bye-bye.